All right, so without further ado, please welcome Kun Pian Pawakapan to share with us on adapting LLMs to low resource language. A round of applause.
Thank you very much. Yeah, hi everyone. I'm Pian. Okay. And I prepared this talk for English, but พูดไทยได้ so ถามเป็นภาษาไทยได้ but yeah, all right. Hello, okay. มันเลื่อนสไลด์ไม่ได้ครับไม่ไปครับกดลงค่ะกดลงได้ครับOkay. Okay, that helped. Thank you. All right, cool. So thanks. So I'm Pian. I'm a senior machine learning engineer from Sambanova Systems. And basically, Sambanova is this company in Palo Alto, California. And we build AI accelerators. So we have our own version of a chip called RDUs, reconfigurable data flow units. And these are basically what they look like. They're an alternative to GPUs. So we're in the business of hardware acceleration. We have our own chip. We build a compiler stack on top of it and the software stack. And more recently, we're in the business of LLM fine-tuning. So we provide LLM services, pre-training, fine-tuning, RAG, any types of APIs, basically. I work in the machine learning team there on the NLP pod, and most of my work is in low resource language adaptation. More specifically, I'm working with SCBX on a Thai LLM project. So this is where the work comes in. And more previously, I've been working in graph neural networks and performance tuning. But yeah, this will be a survey talk based on the work that we've been doing in the company, based on what works for low resource language fine-tuning, what matters the most, and what you should do to fine-tune these models. So, let's see. Let's see. Okay, so let's take a broad look at the state of LLMs for Thai. This is kind of the overview of what I see as the state. It's not really a clear category, but it's the way we see it. And in category 1, we have these, what we call English first LLMs. So these are models like ChatGPT or Llama 70B, which are very, very powerful, but they're English first. They're very good in Thai, but they're very designed for English. Category 2 is these multilingual models, which these mostly grow out the research community. So you have models like XGLM or Bloom or MT0. These are designed to be multilingual. Maybe they're trained from scratch, and they'll outperform category 1 models like Llama or ChatGPT on certain tasks or certain languages, but they don't have huge engineering teams backing them, and they're generally not as powerful as ChatGPT or Llama, but they're meant to be multilingual. And category 3 are these Thai first models. So models that I guess people have talked about in previous workshops, like Wangshan LLM or OpenThai GPT. These are category 1 or 2 models that have been adapted to Thai. For example, OpenThai GPT is Llama 7B fine-tuned for Thai, and Wangshan LLM is XGLM fine-tuned for Thai. So these are models designed for Thai, but they're built on top of other models. So this is a broad overview. And if we're looking at this talk or the topic like adapting models to Thai, one question that we do need to answer is like, why do we even care about these models? Can't we just, use ChatGPT in Thai and Llama in Thai, since they have a much better world knowledge than any model you can hopefully build from scratch. And yeah, they're just going to be better user-facing applications overall. And my attempt at an answer is that, at least from the user side, models like ChatGPT, which are category 1, they're not designed to represent underrepresented concepts, cultures, or identities that are more represented in Thai. For example, as a case study, if you look at Llama 70B and do the dataset breakdown by language, you'll see that Thai is not even in the top 20 languages, as good as the model is in Thai. The Thai dataset represents less than 0.01% of the training data, so this model is not really something that's going to be good in Thai. It's not going to understand most of the concepts that are represented in Thai, and it's more so a English-first model that translates its thoughts and its knowledge of the world to Thai, more so. And that's on the model side. If you look at the dataset side, it's similar. So these are some datasets that are typically used for training or evaluation. XSquad is this multilingual QA dataset. So you're given like a very large paragraph in multiple languages, and you're given a question to answer it. And on the training side, there's datasets like DALL-E and Alpaca using OpenThai GPT fine-tuning. So these are two of the datasets that have been used to train this model. And they're basically human alignment datasets or instruction fine-tuning datasets that are translated from English into Thai, and then they're trained on them. So these are all Thai datasets, and they're pretty good quality. But if you look at the content, these are somewhat representative samples. They're not like cherry-picked or anything. You'll see that they're very about like US-centric or English-first topics. For example, they're about the NFL or locations or concepts or names. They're in the US. And the byproduct of this is, even if you do have category 3 models that are good in Thai, their knowledge of the world is based on English. And they're not gonna be models that know about things that are spoken about on Thai social media, forums. They're not gonna know about Thai sensitivities. If they're models that are customer facing and you care about safety, helpfulness, harmfulness, they're not gonna have notions of what is acceptable to be spoken about, what is appropriate in Thai, or like Thai ways of speaking. So as good as these models are, it's sort of an artifact that they're able to do very well in Thai, because it's not meant to be, they're not meant for Thai at all. And that's the user side. On the research side, I guess the answer is, if we are going to build these models that understand these concepts and represent them well, then it's important to understand the processes for adapting them. It's okay if we're adapting these models from English into Thai. That's good. We're getting like very strong world knowledge, but it is important to get these open source models and understand these processes of adaptation. So how do we do it? And this is basically a breakdown of what the talk will be. We'll talk about the data, so what goes into the model, what we wanted to understand, the architectural modifications and training. So what do we need to change in terms of the model? How do we train it? And also evaluation and deployment, which is how do we choose our models? How do we tell if they're good? Do we have to do any checks before we actually deploy it? This pie chart is split equally, but if we look at it more realistically, it's really almost completely about the data. The other two do matter a lot. Evaluation matters a ton. You do need to figure out like how good your model is, and how you measure it affects a lot. But really your data is like 99% of what affects how your model behaves, what it understands, the way it talks, the way it interacts with users. And we'll break that down for what are the types of data and how we can control that to affect the model. So breaking down by category for the data, what we're looking at is different types of data that go into it and what matters. So pre-training, instruction tuning, human alignment, and then more creative forms of training your models, for example, using translation data. For the architecture side, we'll be looking at a bit about training from scratch, which is fine-tuning for these models. Things like, oh, sorry, I'm standing in the middle. We'll be looking at things like vocabulary modifications. People may have talked about this for models like OpenTide GPT, and then adaptation methods such as LoRa, which has been mentioned, or other adapters. So these affect things on the efficiency side. And lastly, for evaluation deployment, there's the availability of benchmarks, looking at how different evaluation modes optimize different objectives. If you want an NLP model for research versus if you want like an open-ended chatbot, the way you want to evaluate your model and the metrics will vary a lot. So your success criteria differs a lot. And lastly, guardrails and safety, which are very important for deployment and very important when you're adapting to a new culture or a new language. Model that's not ChatGPT. You ask it to answer in Thai, it knows stuff. You ask it like, I don't know, what are some writings by Sunthornpool, and it gives you like 10 valid answers. So it's very, very good. But it's not meant for Thai. Less than 0.01% of its training data is Thai. And that's out of 2 trillion tokens. So maybe that's like, assuming 0.05% is Thai, that's 100 million tokens, which is like maybe a couple of gigabytes of data. So not a lot at all. It's like you can download it in a couple minutes. It's not a lot of data. So basically, this is a model that is vastly trained in English. And as an artifact, it sees some Thai data in the model unintentionally. And magically, it's able to transfer all its knowledge and also understand Thai at the same time. So it's really this English-speaking model, which has thoughts trained in English, but is translating to Thai. It's not really a tribe model in that sense. So let's look at the types of data involved in LLM training. There's a lot of categories, but what I want to talk about is the distinction between pre-training and then the second category, which is instruction tuning and human alignment. There's also categories like RLHF, like human feedback data, but that's something that I haven't seen for Thai data sets just yet. So, and also aspects of RLHF can be distilled into human alignment data. So I'm just gonna stay away from that for now. But pre-training, I assume some people have some knowledge of what that is, but basically you're having these massive text corpuses. Typically they're web scraped, and then their objective is just predict the next token. Instruction tuning and human alignment, these are typically very small data sets. Typically they're less than 100 million samples. They're for fine tuning, and typically they're curated, templated, or sourced. So people do a lot of work on this. It's not just web scraping. And the objective is, given the prompt, you try to predict the completion. So for example, this is asking for like health tips. And there's human alignment is something very similar to instruction tuning, but there's elements of like helpfulness, safety, response style. So that's where you add in things of like, maybe you don't want certain responses, maybe you want your model to stay away, or you want your model to be more helpful for certain things. So looking at pre-training, this is our experience. So we've found 3 major publicly available training corpuses for Thai, and all of them are variants of Common Crawl. So the datasets are MC4, Oscar, and CCNet, and combined after filtering, you can get around 200 gigabytes of training data, which is quite a lot. It seems like it's actually a lot more than Llama's pre-training data, which is pretty meaningful. So first question is it possible to adapt an LLM from scratch to speak Thai? Do we have the resources? That's also up to you guys. So it's going to take a long time. Yep, it's a bit frozen. then I can also say next slide or anything, but.
The PDF post, let me just shut it down.
Oh, no worries. All right, we'll wait a bit. Okay, thank you. Coming up. Okay, yeah, so to continue about pre-training, so we looked at, is it worth it? The next question is in terms of quality. So thinking about like data quality, generally, what the subsets that hold like the highest quality of data are things like books, Wikipedia, WikiHow, and news. But then if you look at these like 200 gigabytes of data, they're mostly like, if you sample from them, you'll see they're mostly data from forums, ads, online betting, and adult content, which is, I guess, the Thai internet, unfortunately. So the bottom line is there's very limited benefit to massive pre-training from Thai due to the compute resources that you have, the availability of high quality data. So it makes much more sense to just fine tune from open source checkpoints in this scenario. Although if you have a massive data engineering team and you can scrape a lot of Thai data, then sure, go for it. So that's pre-training. If we look at instruction tuning and human alignment, so again, this is data that gives the model like instruction following capabilities. The input is like to give a certain answer or to follow in a certain instruction, and the model's task is to predict it. So there's a range of ways of getting instruction tuning data, and there's a lot of creativity involved. One of them is to just template NLP datasets. So there's a lot of NLP benchmarks out there in Thai, which are like hand curated. There's things like QA, sentiment analysis, summarization, translation. These are all like pretty high quality benchmarks. So you can take them and prompt them so they'll look like instructions like this. So if you're asking the model to answer a question or to summarize some text or to classify something, and the response is to, yeah, it is basically the answer to the task. The pros are that there's a lot of available NLP benchmarks here compared to human alignment or pure IT data. And this leads to really good performance on benchmarks. So if you're publishing a paper, this is what you want. And it also learns some instruction following capabilities, which is a useful step for training a model. The cons are that this isn't necessarily what you want from like a chat model or a human interaction model. If you're talking to ChatGPT or like some company's chatbot, you don't want it to just answer positive, neutral, or negative, and you don't want just super short QA answers. You might want, descriptions or follow-ups or reasoning, which is not encoded in this type of data. The second source is to translate IT or human alignment data from English to Thai. This is an approach that's worked pretty well for existing models. For example, if you look at the training data sets for OpenThai GPT fine-tuning, the majority of them is Thai translated. So data sets like Alpaca, DALL-E, GPT Teacher, they're high quality data sets in English, and we're just Google translating them to Thai. And you learn Thai and you learn IT capabilities. The pros is that there's so much more of this data in English and you're getting it in Thai. The cons are that, well, as we first described, this is mainly going to be about English-centric topics, and also the translation quality may be pretty poor. There's some results from, I think, OpenThai GPT and also internally from our work that if you fine-tune on English IT data only, it's actually better than if you fine-tune on English and translated Thai. on Thai. So these bad translations really hurt the model. The third source is distillation or self-generation. So this is basically using a better quality model or your current model to generate some fine-tuning data sets and then fine-tune on them. And OpenThai GPT, for example, fine-tunes with 5K self-instructs samples. So basically it's asking itself to generate some examples and then fine-tune on them. And GPT teacher is, for example, an instruction data set generated by prompting GPT-4. So this method is pretty popular. And the pros are this can lead to huge performance gains if you're doing it right. This is used for a lot of things like code generation, and it's in all sorts of domains, so not just language adaptation. But the cons are clearly if your Oracle model is very costly, it takes so much money to generate these data sets. And if your current model is poor, then you're going to get garbage and be training on garbage. So it can be very hurtful if you're not careful. And the last source is, I guess, carefully curated, very high quality human alignment data in Thai. So there's papers out there like Lima that show that you can take a smaller model like Llama 65B and get this IT data set that's hand curated, like people have written them up very carefully, and they're very high quality, very, very good data. And you can fine tune on it and be as good as GPT-4. So basically a small amount of very high quality data goes a long way. So the pros are it's very, very good. The cons are this doesn't really exist in Thai as far as we know, I guess. We only have high quality data in English for this. And for some extras, there's also some more creative techniques that work for multilingual models. For example, if you look at models like BloomZ or MT0, they'll mix in English and foreign languages with their prompts. For example, they'll ask the prompt in English or foreign language and then ask it to answer in a different language. And this encapsulates some features of performance transfer and translations and learning new languages, which is pretty useful. There's also some work in translation data, which is, I guess, can be used in interesting ways. So the gold standard for translation data is that you'll outsource it to someone and these language experts will translate it, but this is very, very costly. The more popular method out there is to web crawl from sources like Wikipedia or News or WikiHow. These are places where you'll have side-by-side articles in English and the foreign language. And so that's more or less translations. The issue is that on the word level or on the sentence level, these articles won't be necessarily aligned. They're just written about the same topic, but potentially by different ways, by different people. So aligning them is an issue, but using these data sets can be very helpful for your model. So that's mostly about the data. I'll come back and give some high-level summaries, but it's basically don't pre-train, fine-tune from other models unless you have massive resources, and put a lot of effort into finding and creatively getting sources of fine-tuning data. On the architecture side, there's three things we'll be looking at. So obviously the model architecture, vocabulary adaptation, how do we need to change our models to transfer to new languages like Thai, and things like parameter efficient fine-tuning, how do we fine-tune with less resources and still achieve the same gains. So on the architecture side, models for NLP have basically all converged to transformers, and the only question is really how much compute budget do you have. That determines how many parameters you can train for and how long you can train for. So basically, the only choice you're really making for architecture is how big your model is here. For adaptation, so I'm not sure if the previous speaker talked about how OpenThai GPT did it, but basically modern LLMs use byte pair encoding. And this is the nice thing about this is you can generalize to new languages because characters like Thai are represented with the bytes of each character. The only problem is that there's very efficient encoding for this. So for English, for a well-trained tokenizer, you'll have 4 characters per token, each word or subword is basically a new token. But with Thai, you're averaging less than 1 character per token because some Unicode characters are more than 1 byte. So it's very expensive to do this. And if you look at OpenThai GPT, they basically extends the vocabulary from Llama 7B from 32K to 56K tokens. So they're adding all these tokens so the model can recognize Thai more efficiently. And the limitations, if you don't do this, are generation speed. So your model's trying to generate, if your model has the same per token speed in English and Thai, it has a slower per sentence speed in Thai because it's taking more tokens to represent the same sentence. And you're also hitting memory issues with shorter sequences in Thai because one sequence might be, let's say, 4K tokens in Thai, and it's maybe 1K tokens in Thai, and that's a lot more memory, especially if you're training transformers. And there's clear trade-offs between the old and new languages. So this is some work we've done and published at a workshop with some colleagues at Sambanova. So basically we study like Thai and Hungarian, and we decide to not extend the vocabulary or the tokenizer, but replace some tokens for English with tokens in Thai or Hungarian. And we show that there's some trade-offs between how efficient it is on the old language and the new language, how well it transfers, how efficiently it encodes these things, and performance on downstream tasks. And the other takeaway is at parameter efficient fine-tuning. So these are techniques like LoRa, MADX, or IA3. So OpenThai GPT and Wangshan LLM, they're fine-tuned with LoRa. I won't go into the technical details, but more or less they're like these low parameter fine-tuning methods that allow you to tune these models and get the same performance or better compared to full fine-tuning, while using much fewer trainable parameters and much less memory. So maybe you need like 1 GPU instead of 4, or if you're really lucky, you can train on CPU. But yeah, these are very feasible. There's variable performance depending on the domain that you're adapting to, because the assumption that LoRa makes is that your distribution shift between your old and new data isn't that big. And it's unclear how shift that big is if you're going from like English to Thai. Maybe there's a huge gap if your model has never seen Thai before. But there's some research with multilingual models that show that these adapters actually perform similar or better on the new language when you compare it to fine-tuning, full fine-tuning. So this is definitely a feasible approach. So yeah, those are the 3 things that we're looking at for the model side. Lastly, on the evaluation and deployment, this will be pretty brief, but yeah, this is the process of basically deciding how good your model is. And if you're, let's say you're presenting or you're trying to prove whether your model is better or if it's actually improving something, deciding what metric to show or how to get this evaluation matters quite a lot. So if you look at the broad world of NLP research, or if you look at what gets published when a model comes out, it's mostly NLP benchmarks. And these are tasks like QA, summarization, translation, NLI, sentiment analysis. And the metrics are things that are automatically computed, like accuracy F1, blue, and rouge. So for example, these are some tasks that we'll see. This is pretty standard. Basically, they're tasks that are have some, I guess, understanding of, measure the model's understanding of language in some way, and they're computing automatic metrics. Or this might not be what you want for different applications. And what you're using your model for affects the evaluation mode a lot. If you're doing research, if you're trying to publish something, or if you're using the model as a backend for some tasks, then sure, this NLP benchmark approach is very helpful. If like your model's in the backend try to answer some question, then just go with like QA score or accuracy, that's fine. But if you're doing like a conversational chatbot, maybe you want more human evaluation. And if you're doing customer-facing approaches, maybe you want to look at retrieval objectives. So to break it down, different evaluation modes, they optimize for different objectives. If you're doing NLP benchmark metrics, scores like F1 or rouge or accuracy, these will reward concise and extractive answers. F1 score, part of it is like recall and precision. So if you're having like a very low recall because you generate a very long answer, your model might be very helpful, but it's going to get a terrible F1 score. So your model might be good, but the benchmark might be saying your model is trash. So don't always trust it. And vice versa, if your model is doing really well on F1 scores or benchmarks, it might be giving 1 or 2 word answers, which doesn't mean that it's a great chatbot or a great customer-facing application. If you're looking at human evaluation for more open-ended generations, you'll see that these like human evaluation is very subjective. It's basically asking people to choose which model is better. And it values conversational responses, things that have a lot of reasoning, but this might perform terribly on research benchmarks. And lastly, if you're having like a customer application, this might, for example, if you're building a chatbot for a banking app, you might reward accurate information more so than the ability to model language even. For example, if you're getting a question like, what time of day can I withdraw from my investment account? You don't care about NLP metrics, F1 score goes out the window. And this task might be more information retrieval versus actual text generation. And you might care more about evaluating this with a RAG setup or with metrics with like recall or NDCG, which measure like how well your model is doing at retrieving information. And lastly, when you deploy, there's some thoughts about what you're using your model for and things you might have to set up around the model. So guardrails and safety are very culture and usage dependent. If you're deploying a model in a certain country, then you need to change your safety guidelines accordingly. Your helpfulness guidelines change accordingly. How you prevent hallucinations is important, and it's still an open research question. No one's really figured that out. And pre-processing and post-processing can be very useful techniques for deciding like which queries or which model outputs you want to avoid, where you want to regenerate or not. So these are very basic ways for dealing with these issues. So yeah, that's the end of the talk. To summarize a few takeaway points, they're mostly about the data, but yeah, so clearly the state of the art is in fine tuning. There's a lot of work and a lot of startups that have come up and are basically around fine tuning smaller models like Llama 70B or 7B and beating ChatGPT on some particular use case. So it's purely fine tuning. All of it is based on how good your data is, what type of data you choose, and the specific domain that you're using it for. On that note, creativity and instruction tuning and alignment is also key. There's a lot of methods like self-instruct, using distillation, requesting data from other models, curating very high quality data. That has a huge effect on your downstream model task performance. And if you're doing it for low resource language data like Thai, getting this high quality data is very crucial, but it's quite missing currently. And lastly, the architecture and training considerations that you're doing, these used to affect your accuracy a lot, but nowadays, especially with language adaptation, there are concerns about efficiency more so than accuracy. If you change your model, if you're doing LoRa or full fine tuning, if you're changing vocabulary, typically your model won't get better, but it's going to get faster. It's going to cost less to train. It's going to cost less to do inference, which makes a lot of sense and means a lot to the use case, but it's really in terms of efficiency and less so about model quality. And yeah, hopefully that's the end of the talk. Hopefully that was helpful in some way for the hackathon. And yeah, I'm open to questions in Thai or English or anything. Thank you.
All right, you have seen the challenges. Now it's your turn to ask away, or maybe suggest, or maybe discuss. It's still really early days for Thai language as a useful model. So if you want to share anything, ask anything, please feel free to do so. ครับ อยากถามเจาะเรื่อง
ทำข้างนอกก็ได้ครับ แต่ไหนก็ได้
ถามก็ต้องได้โอเคนะครับ ก็เดี๋ยวไปคุยกันเจอกันตรงนี้ได้เลยนะครับ ก็ขอบคุณมากครับ thank you very much ครับคุณเทียนภวัชพันธ์นะครับ alright and now